Today I'm discussing a Sudoku game that I recently created using Python. Let's jump right into the demo. So after running the program, a window pops up prompting the user to select a difficulty for the Sudoku. The options are easy, medium, hard, and evil. For now I'm going to choose medium. The Sudoku is generated and drawn on the window, and its initial values are just drawn in black. Their cells are also highlighted in a dark gray to signify that they are locked cells. For anyone who hasn't played the game of Sudoku, the objective is very simple. Every box, row, and column consists of 9 spaces, which have the values 1 through 9. The objective is to fill every cell so that each number only appears once in every box, row, and column. The elapsed time is displayed above the game area. The user can select any cell inside of the Sudoku by clicking on it. This highlights said cell if it isn't locked, and also highlights the surrounding box, row, and column. The user can assign values to the unlocked cells by typing in a number key on the keyboard. If the number is incorrect, then I change its color to red and highlight any conflicting cells, which in this case is 1. If its number is correct, then I simply change its color to blue. The user can enable or disable hints at any time by pressing the hints button. Right now the button is green, meaning that hints are enabled. Pressing the button disables hints and changes the button color to red. Now whenever you put a number on the screen, you won't have any indication of whether that value is correct or incorrect. I'm going to turn hints back on for now. There are a couple of other buttons that the user can interact with. The New Game button creates a new game with the previously determined difficulty. The Change Difficulty button allows the user to select a new game with a different difficulty. The Notes button allows the user to add notes to the selected cell. This helps narrowing down any possible Sudoku values when they're trying to solve it. A green notes button means that notes are enabled, and a red notes button means that notes are disabled. And finally, the solve button uses backtracking to show the game being solved in real time. I'll demonstrate that in a little bit. First, I want to add a couple of cells to the Sudoku. So these numbers aren't necessarily going to be in the correct place. It is kind of difficult trying to solve the Sudoku and demo it at the same time. So one of the cool touches that I do is whenever you enter a number into a cell, I also get rid of any notes that are in the same row, column, and square. So for instance, I'm going to hit 1 and it's going to delete all of the notes that have a 1 on it. This makes it easier to manage notes by deleting values that are no longer needed. In order to delete a cell value, you just have to type that number in again or type a 0. Now that I've filled in a couple of cells, let's hit the solve button. Seeing the backtracking algorithm in action never gets old. I must have hit this button at least 100 times and it still feels awesome every single time. Once the Sudoku is finished, a total time for the Sudoku and the final solution is displayed on the window. The user can choose to either start a new game, change the difficulty, or quit the program. For now, let's change the difficulty to evil. On the evil difficulty, it becomes extremely difficult to figure out where each value is supposed to go. Lucky for us, we have an algorithm that is up to the task. I am going to give the algorithm a little help though, just because evil difficulty is very scary. So it may take the backtracking algorithm a while to figure out the correct sequence, but once it figures out the first couple of rows, the algorithm solves the rest of the Sudoku very quickly. I'll let the program run in the background while I go over the code. Instead of covering everything in detail, this time I'm just going to highlight the significant parts of code. Let's start with the button class. It has all of the basic variables that keep track of the button's position, its text, color, height and width, etc., etc. The class also has functions that update, draw, and change the different aspects of the button. One of the small features that I really like about the button class is that when you scroll over the button, it changes to its background color. This is a subtle feature, but I think that it really does make a huge difference. With that out of the way, let's get to the cooler stuff. So this class is where all of the game logic takes place. There are a lot of different event, game state, and button handling functions for each of the different game states, which are playing, finished, and change difficulty. There are also a bunch of functions that deal with displaying the Sudoku and changing the board values. I considered moving these functions into their own classes, but I ended up keeping everything together. The scope of the project isn't really big enough to warrant splitting these functions into their own classes, in my opinion. So here's where the exciting stuff starts. I use a bit of web scraping to retrieve a Sudoku from the internet. I actually have the web page loaded on my internet browser, and here is what it looks like. In order to get these values, I use Beautiful Soup to retrieve and parse the game information from 9.websudoku.com. I then retrieve the online Sudoku values located in the parsed data and append them to my Sudoku. This saves me a lot of time and effort because I didn't have to generate my own Sudoku. There's no need to recreate the wheel here when it's readily accessible to the public. The other highlight of the project is the use of artificial intelligence to solve the Sudoku. I was wondering how I was going to solve the given Sudoku, and then I stumbled across backtracking. The logic is very sound. You start by filling in an empty space with a number. You then iterate to the next empty space and do the same thing. This process continues until the algorithm becomes stuck and unable to solve the Sudoku correctly. At this point, the algorithm backtracks to an earlier point in time and tries to solve the Sudoku with a different value. This process continues until the algorithm successfully solves the Sudoku, given a solvable Sudoku as input, of course. It is possible to send an unsolvable board as an input to the backtracking algorithm. The backtracking algorithm will attempt to solve the board and eventually get to the end of the function, where I double check to make sure that the board was actually solved before returning the result. The backtracking algorithm can handle unsolvable Sudoku inputs. I do, however, take a few extra steps to ensure that the algorithm isn't wasting its time trying to solve these unsolvable Sudoku boards. First, when I retrieve a new Sudoku, I make sure that there are no conflicts between the given initial values. If there are, I simply keep getting another Sudoku until no conflicts are detected. After I get a solvable Sudoku, I then solve it immediately using backtracking so that I know the solution. Then, whenever the user wants to solve the Sudoku, I remove all the incorrect cells that are on the current board that the user has put. I also take note of which cell values are correctly placed on the Sudoku to save some time when executing the algorithm. Now, I can technically just display the solution since I already have it, but I find it a lot more satisfying actually seeing the backtracking algorithm in action. Since visualizing the algorithm is a pretty niche application, I decided to just create a new function that incorporates the functionality of displaying the backtracking algorithm. That is right here. Just adds in the ability to quit while the board's being solved, and also displays the board being changed and adds in a small delay, just so we could actually see the numbers appearing on the screen. That about does it for this demo. Oh, I did forget to mention that I also print out the solution at the bottom right here after I generate the new Sudoku board, just so that I have the correct cell values. Anyways, I had a blast learning how to use Python. It definitely took some getting used to, but Python turned out to be a really fun language to use. As always, if you have any questions, ask away and I'll be happy to help in any way that I can. Thank you for tuning in and enjoy your holidays.